an open data files file name, and that's what you
Go
can
back
do.
to that, please,
But then
because
how did you do
this I have some people that are telling me you click. No, go right back to where you were.
File,
data file?
Yes, and then stop. Hold on just a second. Some people are clicking on group number, double clicking on that, and then some people are clicking on file name. So what are
no,
you supposed to do?
file name.
It's file name.
Okay, you have to.
What you're looking for.
Okay,
Yeah.
okay.
We're not messing with group number.
But if you double click on it, so if you double click on it, it does the same. Double click on group number.
Okay.
No, no, the blue. Double click on that.
Oh, it does the same. Okay, I
Okay.
didn't even know it did the same.
Okay, because that's where I was getting confused.
I was going for more obvious like file name. As a matter of fact, most of the time I don't even go to the menu here. I just go to the equivalent icon, which is this one here. Yeah. Okay. Anyway, you got some delay here. Let me. So I selected the right file now, which has the product of tenure and LRC. Okay. I'm just going to do this way, which is the product approach, right? So what all I need then is to bring that variable here. So it's the product of tenure, the standardized version of tenure, and the factor score of LRC that I had previously saved. And I will go here, and because it's an independent variable, which we call exogenous variable in SM, you have to put all the correlations.
What about the tenure multiplied by x1, x2, x3?
I was meaning to show you that way, which is the alternative way,
Okay.
but I couldn't. I was having trouble downloading my file, so I had to abandon that.
Okay.
When we take a break, I'll get the help and say, hey, this worked yesterday. Why didn't I can download the file? I don't know why. But okay. So I mean, it seems from what I could tell that the UF apps worked very well. Otherwise, the only thing it was really having a problem with is downloading the file. Like I can upload the file, I can open SPSS, I can run everything, but downloading was just not working. Okay. I mean, I could have cheated. I could have opened my email on UF apps and emailed the file to myself, or open Dropbox or OneDrive on UF apps and uploaded the file that way, right? I was trying to do their way, which is supposed to be Control C, and you hold Control C, and he showed me yesterday, and then it shows a download thing, but for me, it never happened. Okay. So, I mean, otherwise, it seems like the UF apps is an improvement of older versions, because I used to use UF, I have used UF apps for a long time for class, and the older version, if I had too many students using it at the same time, the thing would crash.
It still does. It still does.
It still does?
Yes.
Yeah.
Oh, okay.
That's what happened.
The other group is using it and it crashes on us and it crashes on them.
Oh, okay. So if they still have that limitation, like
Bless
not
you.
enough whatever licenses that they are paying.
Yeah, there's some.
Okay. So, okay, this is ready. Right, notes that I put the correlations, I put tenure here. It's an observed variable. I just need to save these. And then run. Okay, it ran. See, I got an estimate here. It's not statistically significant. Let's look, but I bet it's not because coefficient is quite small. So if I go to, so model fit, it's no exact fit, as you can see, probability level 0.018, but close fit is fine, .98, .98, .98 for IFI to CFI. And then for root mean squared error, I got 0.03, which is less than 0.05, so I'm good too. So model fit is good. Now, estimates. And then I have my interactions, this one here, tenure LC on performance. The estimate's 0.01, listed error is 0.053, p-value is 0.845, so not statistically significant. So the conclusion here is that there is no interaction between performance and LRC. Okay. Now, from her interactions are between different because hers are between a binary variable and so 0-1 variable and interaction. So she could do it with one binary variable, like she could create a product of the binary variable and the factor score of psi, right? But it's not the preferred method. Multiple group SM is better. Now, if your sample size is not very large, that may be what you have to do. People in this class have to do sacrifices because of sample size limitations all the time. You know, few of you get to have thousands of responses. Now, does any of you here have an interaction between a latent variable and a continuous observed variable in your model?
What continuous observed variable is tenure?
Tenure is continuous because it's years, right?
Yeah.
You can go down to months, you can do minutes. That one is truly continuous. Yeah. Okay. So yeah, if you had that's how you would do. So, but this method actually generalizes, you can use it for two latent variables, right? I could have done, for example, the product of the factor score of LRB and the factor score of BSC, right? It's a valid method. Although I prefer to do what we did yesterday, which is the product of X1. We did X1 and 2, you know, we matched them by factor loops. Okay? Okay, let's look. Any questions about how to run the interactions? From particularly the 12 of you, like anything from your particular example that you think is going to be tricky and you want to ask me right now?
So can I ask, so age and tenure are control variables in your example, right?
Yes.
And you just did the interaction with tenure. Do you have to do it with all the controls?
No, interactions are theory based.
Okay.
Yeah. I mean, from a statistical perspective, you know, control variable is something that you think is a confounder, you know, but you don't have a hypothesis about. You just want to control because it could, you know, for example, if tenure is a confounder, it means it relates to both LRB and performance, which would provide a path for this relationship, right? But you could have a legitimate hypothesis too, which would be that tenure interacts with LRB, right? So from a statistical perspective, whatever your hypothesis calls, if you hypothesize an interaction, you can specify. If you don't have a hypothesis, like let's say I don't have a hypothesis, I want to control for age because age is a confounder, but I don't have a hypothesis about the interaction with age, then there is no reason for me to put that interaction there. Okay, it's totally hypothesis driven. Okay. Yes.
Go ahead. I think I do have a combination that you were saying. So it's one of my dependent variables is job performance, and it's going to be from customer satisfaction scores. So that would be a continuous variable.
Yes. If are you doing job performance as a composite or a latent variable? Like, in other words, being more specific, you said that you have multiple scores, right?
It would be a composite of a couple different scores.
Oh, so you are doing the like score 1 plus score 2 plus score 3, rather than doing the performance as a latent variable with the scores as indicators?
Well, I haven't finalized that yet, but I was thinking it was gonna be just the raw scores.
So you average or sum them.
Yes.
Okay. So it's fine. Just remember the limitation, right? If you do this, you're assuming that the scores have no measurement error and that they are equally important, right? That you are weighting them the same. If you do this, you're controlling for measurement error, and the scores are are weighted by the factor locus.
Well, what should you do?
This is preferable.
That is preferable?
From a logical perspective, right? Strong assumption that they are equally important. Weaker assumption, you always go with a weaker assumption if you can, that they are not equally important, that some components or some of your scores will be better measures of performance than others, and that some of the error, some of the variability is not related to performance. Because if you do this here, like you estimate the measurement errors, right? So you're actually separating, for each of these scores, you're separating the variance that's due to performance from random variance. Over here, if you do this, you're combining everything.
Okay.
So this is always preferred. If you do this, you are making a sacrifice. It's like a literal limitation you have to declare at the conclusion of your dissertation.
And I do not want to do that.
Yeah, but sometimes, like maybe your sample size is not large enough. There is no research without sacrifices, right? There are always, everybody will have a limitation section. There's no, so you have to figure out, can you do this with the sample size you have? It's better if you can, or else.
Yeah, I hadn't even thought about the two differences there, so
Yes,
I'll definitely just go with
that's
the
very important.
latent.
Composite versus latent variable. Okay, so if you go this way, you can do the product indicator approach. What's the so performance is not the outcome. Performance is a predictor.
Performance is its outcome.
Okay. So what's going to be interacting and affecting performance?
Well, the mediators that are the closest to it are burnout, anxiousness, and attentiveness.
So the mediators, they mediate and they moderate?
No,
They just mediate.
just mediate.
But you said you also have
Moderators, servant leadership, and resilience.
So servant leadership and resilience are going to interact.
No, their servant leadership and resilience are just moderators from my independent variables.
Well, yeah, but moderation and interaction is the same thing, right? Like what?
So if you have two
interaction
moderators, you have to have an interaction effect of the two?
They are both. They are interacting with something, right? What are they interacting with?
It's a complicated
They're not
model.
interacting with each other. They interact with
I don't want to
something.
waste the
Okay.
class's time.
Okay,
I'll have to show you later. It's
Yeah.
a little complicated.
Just remember, like an interaction effect. This is interaction effect is the same thing as saying that the effect of RRB is being moderated by tenure. So if you're saying you have moderation, it's because something is interacting. You have a product.
The
Okay.
the dependent variables is challenge and hindrance stressors.
Okay. We will have time to talk about yours in detail because you're going to present it
Yeah.
to us.
Yeah.
But yeah, you'll have a nice drawing.
Mhm.
Once you have a diagram like this, it
Yeah.
becomes much clearer. And maybe you run into a situation like hers where like she basically had to rethink some things, right?
Absolutely,
Yeah,
yeah, it's
yeah.
helpful.
Okay, so let's look at before we move on, because let me show you one final, just a final paper that I posted it on a paper that looked at moderation. I posted it on Canvas. Let me try to get Canvas here really quick. Well, you see it. I will pull it from my computer. Okay, we're going to be looking at this paper here. The paper is not means in Potsdam quality. There are some issues, but it does serve as an example. So here, under at the end here, I put day 2 part 3. I put example with latent moderation. Portfolio on 4 2021. Okay, and that paper. Okay, you see that I added a couple of comments to the paper. I will go straight to the bottom. Now, they did not use Bates and Potsdam scale, even though they're interested in voice. That by itself would probably raise Dr. Potsakov's objections, right? They use the alternative scale that is measuring two different constructs, promotive voice and prohibitive voice, which is one of the constructs that Bates and Potsakov tested against, developing the scale. But you can see here that they putting that leader humor, that the relationship between leader humor and psychological safety depends on team humor, right? So if you were to test this, you would create products of the indicators of leader humor and team humor, and then use those products as indicators of a latent variable that would be called, team humor times leader humor, right? Call them you can call the latent variable just interaction. The name is arbitrary, right? Now they did find significant interaction here, okay?
It's negative.
It's negative. And to interpret this, they had to come up with a figure, right? Like I was showing you on the board yesterday, that the way to interpret an interaction is always through graphics, right? It's hard to interpret it without visualization, okay? Now yesterday when I was showing you, I was recommending doing quartiles, like 25th percentile, 50th percentile, 75th percentile. They did it binary instead. They did low leader humor, high leader humor, low team humor, high leader humor. I mean, it's, I guess, simpler, fewer lines. So it's showing that that the slope changes. So for high team humor, the relationship between leader humor is weaker, right? The increase in leader humor, the increase in psychological safety as leader humor increases, that increases is expected to be lower, right? So it's a weaker relationship than for low team humor, which
A funny boss has more impact on a lame team than a funny team.
yeah, I guess yes. That's a good way to put it. Yes.
Michael Scott.
Yeah. So if for all of you, that have interactions, if you find a significant interaction, you have to spend some time thinking about creating a graph like this, how you're going to plot it, to show what's going on. Okay. Now, I put a few comments here just for things that I objected. Like one is the original model. Look at the fit of the original model, the CFA model first. Look at this. CFI is 0.87, TOI 0.85, root mean squared 0.09. Does this model have closed fit? Does with the CFI, let me make it bigger, with the fit results that they reported here, right? Does it have closed fit?
CFI is greater than 0.95, right?
Yeah.
So that means
No, and they say that poor fit of the data, right? So they have to revise the model, and they did it by adding some correlated errors, right? So they basically, I can show you on my model here. They basically did this. Correlated errors look like this. Like they picked some variables and said it did this, right? And so basically this is saying that there is something here, some unobserved factor, more than one observed factor, that makes these items correlate above and beyond BSC. Okay, it's usually a method effects problem, which the Potsakov article talks extensively about different sources of method effect. Okay, now what I don't like, well, first you have to avoid this situation like the plague, right? Because this is basically saying there is something here you can't explain, right? So Potsakov, in the different, he shows different structural equation models that you can use for method effects. Adding a correlation is not a great one because it's basically saying, yes, there is a problem. I don't have no idea what it is. Okay, you're putting a band-aid on it. Like putting this will make your model fit well because you're allowing the correlations that exist, but you are clueless about what is actually going on. And that's what they did. And worse than that, they didn't even say which items, right? So they said, based on modification indices, based on modification indices, let me classify this statement here. What they did is, after they ran the model, well, before they went here on analysis properties and clicked on modification indices. And what modification indices does, if your model fits poorly, it will indicate which error correlations or which factor loadings you can add to the model to improve fit. And it will show you how much the chi-square will change for each additional path you add. Okay, is not a great way to improve a model because it's completely data-based. Like it may not generalize to another data set. Like there is no theory behind it. It's like, oh, I'm letting the software calculate for me which correlations I can add to make my model fit better. Okay? Yes?
Can I just ask in real world what's happening here though? Because you've got these questions that are being asked potentially on a survey, right? And let's say there's 5, and they're finding that 2 or 3 of them are similarly worded, and by correlating the error, what exactly are they doing with those questions?
They're saying that, okay, let me make it even more concrete here, right? Let's say that that these 2 here, M1 and M3, were from a survey.
A lot of surveys have very similar questions.
Yes, but
especially the longer ones.
But these 2, like if they are all from a survey, that you have what's called a monomethod bias. Like they are self-report, but you cannot separate that source of bias because they're all common, right? What would be a different situation is if some of these were supervisor reported that some of these were surveys, right? Then you would be able to put a method factor here, right, where you could put supervisor.
And just as an example, I'm considering doing that for my job performance, using survey results that these employees get and combining that with the managers ranking those
So
employees.
this would be accounting for a method effect here.
Yeah,
Yeah. So I would recommend it, like the Potsakov article has a very nice table and a decision tree on how to decide. You know, this is a multi-trait, multi-method model, which is one of the best ways to account for this.
yeah.
Right.
That would be very similar to what I'd be doing.
So, but if they all surveys, you cannot separate. We have what's called monomethod bias.
Correct.
You only have a single method, so you cannot separate.
But going back to the error or the problem that was in this one, what happened?
Yeah, so they don't say, and that's why I criticize the article. They said, based on modification indices, we made a few changes to the hypothesized model by correlating the error terms of 6 pairs of items within the same factor that were similarly worded or shared similar meanings.
Why did that help their numbers? How did that help their numbers?
They help because they...
It's like if they grab whatever in the data. It's
Well,
not
okay, let's say it helped because they are allowing the model to have that correlation. So let's say this is the items, right? Let's say E4 and E6 have similar wording, and the similar wording makes them correlate beyond what is explained by the factor. So by adding that correlation, they're allowing the model to reflect that, right? So you are adjusting a model to match what's happening in the actual data collection. And so the other thing they said was similar wording or shared similar meanings. Let's say these two had similar meanings, they could have done this, right? Again, it's not ideal, and they should have elaborated. They should have said which items those were. You know, their statement there means they don't really know. They're kind of speculating.
Isn't that confounding?
It is confounding because essentially they're saying there is something here that I don't know what it is that that makes them correlate the residuals to correlate, and because they don't know, they put the correlations between residuals to allow, so to prevent poor fit. Because if you are allowing the correlations, the models will fit well because you are not saying that they are zero. You are allowing them to exist in your model. That puts a band-aid, in other words, that allows the model to fit well with something that you really cannot explain. You know.
Is it plausible that they had to cut their explanation due to space? Maybe the reviewers are like, it's not relevant to cut this, or do you
It's a
think
validity. I mean, yes, but I would disagree with that prioritization of space. It's a validity problem of their scale, right? And you can't really interpret if you have a validity problem. It can't, I mean, limitations are okay, but you know, you gotta explain them to the extent possible, right? They could have done better. Okay. And the other thing that they did that it really did not, they did cite Potsakov here, and they used the method to call the harmless single factor test. But then if you read Potsakov specifically say that method is the worst, it's terrible, and they abandon it in the paper. Like, they review it and they say, because this method has so many problems, we're not going to talk about it further. And then in the recommendations, this method doesn't appear at all. Like, they basically say, don't use it, right? So it's always funny, right? They cite Potsakov and then do something that Potsakov recommended against,
Wow.
right? Yeah. So those are my 2 notes on this paper, but it does serve as an example.
But it got published.
Yeah. I'm sure the journal, I don't know the quality of journal leadership organization studies, but probably not as good as Journal of Applied Psychology. So, but yeah, it got published. Things get by reviewers all the time. You know, it's a bit of a draw of luck, right? The other day I reviewed a paper that I happen to know a lot about the methodology. I saw like all sorts of serious flaw. I wrote a review basically destroying, say you have to, the topic is interesting, the data is interesting, you have to redo your entire analysis with completely different methods. And then submitted. And then a few days later, you know, the editors always send their recommendations to the review so you can see what happened. And they put both the reviews. So the other reviewer said, great article, publish, you know, and I was completely destroying it. So the reviewer, the editor made a decision in the middle, right? It said, revise and resubmit with major changes. You know, so maybe the author's could have been lucky and got the two reviewers like the first one.
Crazy.
And it would have been approved, you know, even though I said what they were doing was completely not valid. You know?
That's crazy.
So it's a bit of a gamble, you know. Okay. But here we try to do things in a rigorous way, even though we were aware of limitations. Okay, so let's talk. We only have an hour left. I want to talk about validity some more. You know, we already started because this paper has some validity problems. So structural equation modeling is a good tool to provide evidence of validity. So what I have here is a reading that talks about scale development, more for organizational perspective, and then this is from a measurement book that we use in my program that goes over like the modern conceptualization of validity, and I want to show you how. I'll open this slide. How structural equation modeling can provide different sources of validity evidence and reliability, right? So we start with reliability is a type of validity evidence because you can have reliable scores that are not valid for the purpose you want to use it. So you must have reliable scores to have a valid use of the test. But having reliable scores does not guarantee that the use of the test is valid. Very simple example. I can measure your height with a ruler, and that will be a reliable measure of your height. But what if my proposed use of your height is to classify you as good drivers or bad drivers? That will not be a valid use of those scores, even though the scores are reliable, right? So the reliability refers to how much measurement error the scores contain, right? So the conceptual theory is that an observed score is equal to true score, which would be the latent caused by the latent variable plus random measurement error. That's exactly what confirmatory factor analysis does, right? Confirmatory factor analysis takes the observed score and divides it into the true score, which is the part that's due to the latent variable plus measurement error. Okay. Therefore, you know, there is this reliability index here, which it's not how we calculate reliability, but it's conceptually is what reliability is. It's the the variance of the true score divided by the total variance. Okay, we use Cromax alpha and coefficient omega. Cromax alpha by far is more used, but coefficient omega, which I'll show you in a minute, is better. Okay, so the Cromax alpha is used a lot because you don't need to fit a confirmatory factor analysis to estimate Cromax alpha. Okay, you can estimate it with raw data because it is just, you only need the variances, right? The Cromax alpha is just a function of the variance of the items separately. So this is the sum of the variances of the items divided by the sum of the total scores, which is the composite. Okay. However, this illustrates a bit of the problem of Cromax alpha, that Cromax alpha relies on total scores. As I was telling him, total scores ignore measurement error. And total scores also assume that items are equal measures of the construct. So Cromax alpha always assumes that your items are equal measures of the construct. We call that parallel items. So it has been shown that Cromax alpha is an underestimate of reliability, right? So if you calculate Cromax alpha for your scores of your scale, and it's 0.7, the true reliability will be higher than 0.7, okay? And I think that's why people still use Cromax alpha, because it's an underestimate. I think if it was an overestimate, it would be more problematic. But it's still, and it's easy to calculate. Now, someone was asking me, if you can fit a CFA with just 3 items, why have 5 items? Why have 10 items? The answer is usually longer tests tend to provide more reliable scores. Okay, and it goes from the formula. The longer tests, the variance of the total scores will tend to be larger than the variance of the sum of the variances of individual items. So this denominator here will grow faster than the numerator. Therefore, your Cromax alpha will tend to go higher. But conceptually, it's like you have more opportunities to measure if you have more items. Okay, and from a CFA perspective, since de facto loadings are the relationship between the factor and the item, the higher the factor loadings, the more reliable variance. Therefore, reliability will be higher. Okay. Now, I'll show you how to compute reliability using CFA, and it's this is called composite reliability or coefficient omega. It's better than Cromax alpha because it does not assume that the items are equal measures of the construct. Okay, I put a citation here for the procedure, but this is the procedure. It's the sum of the factor loadings squared, and the factor variance, you can set the factor variance to 1, so most of the time you can drop this. If it's so, if you use standardized factor loadings, the factor variance will be 1, so you actually don't need this. So it's the sum of factor loadings squared divided by the sum of factor loadings squared plus the sum of error variances. Okay. So for example, now there is this alternative here. If you had residual covariances, most of you won't have it. Remember, residual covariances is usually due to method effects, and you should avoid having that problem. So for here, for example, let me run this again. Actually, I can just click here. Oh, no, I need to run it again. So that's right. So if I wanted the composite reliability for LRB, these are the standardized factor loadings. So my reliability so we use an omega coefficient omega, or also known as composite reliability slash composite. Would be the sum of the factor loadings, so 0.867 plus 0.962 plus 0.88 squared divided by the same thing here, right? So let me see what that is. Okay, that is 7.38. So 7.38 divided by 7.38 plus the sum of the error variances. Now, my error variance is 1 minus I squared. They're here. Double check if they're standardized. It's like probably just do 1 minus I squared. Let's see. This one, R squared is 0.752. The error of 1 is 0.265. No, these are not standardized. So I want to do 1 minus I squared for the error variances. So I'll do here for the first one, these two. Right. So 0.75. So 1 minus 0.752. The error variance is 0.248. So 0.248 plus, okay, 1 minus 0.925, 0.7 plus, and the last one is the I squared is 0.788, so 1 minus 0.788. Oops. 0. So what I did here, right, I took what the I squares were, and I did 1 minus the I squared. I got what the error variances were, okay? So that's the proportional variance that's due to error. Therefore, the coefficient omega here is 0.78. Squared. I forgot to square, so I have to square this. Actually, no, I don't have to square it. They are already squared.
Where did you get the 0.248 and those other numbers? I got lost there.
I took the R squares, right? I don't need to square those. They are already variance. They squared. I took the
Oh.
R squared and I did 1 minus. Okay. Sorry, I just 7. Sorry, I messed up my calculations here. 7.38. Okay. This is equal to 7.915. Therefore, the coefficient omega is 7.38 divided by 7.915, 0.93. Okay? That's the coefficient omega. Now, SPSS can do Provex alpha, and I believe can do coefficient omega too. Let me double check. I'm back to UFMs. Okay, I'm going to open one of the data sets that we looked at, either one, the one with effective scores, or the one doesn't matter. I just did the items. here I have multiples. I'll open the original one. Right, so I have here x1, x2, x3. Those are the indicators of linear relational capital. So I can analyze, and then scale, and then reliability analysis. And I do items 1, 2, 3. These would give me Chromax alpha. Oh, it does give omega as well. Can I give, let me see. Oh. Okay, so let's do omega here. 0.933. Okay, agrees with what I got. McDonald's omega, coefficient omega. Now let's do Chromax alpha. So analyze, scale, reliability analysis. The items are there. We're just going to change these to alpha. Yeah, it really did not make much difference here because, actually, I should ask you, see if you remember, why, for this particular example, Chromax alpha and coefficient omega are pretty much the same?
I'm gonna guess or speculate it's because there's only 3 items and it impacts the degrees of freedom.
Remember, okay, think about the assumption, right? Chromax alpha assumes that the items are equal measures of the construct, and coefficient omega weights the reliability by the size of the factor loadings. Like, it does not assume that the items are equal measures of the construct. If you're getting the same results, what does it mean about the assumption of Chromax alpha?
So the factor loadings are all equal, or?
The factor loadings are very close to being equal, right? So the assumption that Chromax alpha is making is reasonable, right? That the fact, and we can look at that in our actual model if we go back to.
Because isn't it 0.867, 0.962, and 0.888? Are those the factor loadings?
Yes, those are the factor loadings. So they're similar.
They're very similar.
Yeah. Therefore, it did not really make a difference.
It'll make a difference if one's at 0.2.
Yeah. Now, if you have a 0.5 and then the other one's 0.9, the other one's 0.7.
Although you wouldn't use one that would be 0.2.
Yeah, not 0.2, but people do 0.5, 0.4 even.
Yeah.
You know, and then would make a difference. Chromax alpha would be lower because Chromax alpha is assuming that they are equal, and coefficient omega is not. So coefficient omega is better than Chromax alpha because of that. Okay. Okay. So let me.
So why aren't more people using coefficient?
Because they're not taught. Usually, this is taught in structural equation modeling courses, but Chromax alpha you learn about it like in an intro to measurement class, right? So one is take my college for example, right? You learn Chromax alpha on a class you take on the first year. You learn coefficient omega on a class you take on your third year, right? Most people, if you want to go that way, most people don't get there, right? That's why, and I think that generalizes to the entire country. Just people don't learn about it. Chromax alpha is a lot more. It's taught more widely, especially because to fully understand coefficient omega, you need to understand what a factor loading is, right? The relationship with the latest variable. Chromax alpha is based on variances. Like you learned that in.
Well, and you said Chromax alpha was conservative. So if you pass the bar, you're passing it by probably more than you
exactly.
think.
And that's
so it
another
maybe
reason.
compensates for the fact that this other version, while more accurate, it doesn't have the same.
Well, it does you a favor, right? Using Chromex Alpha does you a disfavor because your reliability is probably better than what you're reporting.
Right.
Right? So, and I think that's another reason Chromex Alpha. So I think Chromex Alpha is still very popular for two reasons. One, it's taught more frequently. It doesn't require the knowledge of structural equation modeling. Two, it's an underestimate. So underestimate is less problematic than an overestimate.
So if you're trying to get published, Chromex Alpha might be more understood or well known, and
Yeah, but it depends on the journal, right? If you put it in Journal of Applied Psychology, they will appreciate that you're using a better coefficient. If you go to a journal that's not it's not as high ranking, the reviewers will not know the difference.
and maybe I wasn't looking for it, but it just seemed like we've seen a lot of Chromex Alpha in our papers that we've read.
Yeah, because again, it's way more popular. You know. So it's important to understand like the limitations. Okay, so now, okay, so in terms of validity, right? We classify validity evidence in different ways, and I explained that these are the modern terms, like evidence based on test content. Organizational papers, you see this as content validity. Evidence based on internal structure, actually, evidence based on response process is usually done based on cognitive interviews, like you have the respondents respond to the item aloud, and you see if they are understanding, and you ask them questions to see if they are understanding the item the way you intend. Internal structure, this is where CFA comes from. It's is the item are the items relating in the way you expect them to relate? Okay, so this is what's called construct validity, and then evidence based on relations to other variables. That's what's known as predictive validity. Okay, and evidence based on consequences of testing. This is more relevant to high stakes testing, because like what's the consequence of requiring Florida students to take the Algebra 1 end of course exam in order to graduate high school, right? It's not something that it relates much to organizational research unless you are looking at HR and you're looking at tests that are being used for HR decisions. Those would be high stakes. But if you just your case, right? It's you are doing testing for research. There won't be any adverse consequences. Okay. Now, I'm not going to go up each example. You can look at the examples later. I want to show you, and you can also
I have a question. Whenever someone says they have a validated questionnaire or survey, is that always the same, or is it different for each validation?
Okay. First,
I just didn't know if there's a standard for all of them. If you made that
no, that is first because you have to remember what is it? That the definition of validity is that validity refers to the degree which evidence and theory support the interpretations of test scores intended by the proposed use of the test, right? So if they use it for different purposes, the validity evidence does not translate, okay? And also, there is a difference between surveys and scales, right? Surveys usually don't measure latent variables. Scales do. I don't know if I answered your question.
No, I just, sometimes people throw around like this is a validated scale, or,
That usually when they say that, they mean that there has been a study like the Mains and Potsakov study that provide multiple sources of evidence of validity, right? But you should not take their word for it, right? I mean, one thing is a Mains and Potsakov study that's a very solid study, right, with multiple sources of evidence of validity. Another one is they just did an exploratory factor analysis, and they call it the validated scale, right? So never, when they say that, never really take their word for it, because people abuse. And the other thing to keep in mind is the proposed use. Someone may have done a pretty comprehensive validation study with a certain population, but you are using it for a different population, right? And that limitation applies to any scale, even Mains and Potsakov. If you look at who are the participants, right, that they use in their study, their validity evidence applies to those participants, to that population of participants, right? If you are using it in a completely different context with a completely different population, the validity evidence that Mains and Potsakov gathered does not necessarily apply. Okay, so and that's why I told you, like, you all think you probably using some scales that may not necessarily be. You may not be using all the items of the scale. You indicated that yesterday. You may not be using with exactly the same population the scale was validated with, and therefore you should do some validation yourself as part of your dissertation, right? You cannot just cite the previous study, right? You know.
But what about surveys?
Surveys tend not to measure latent variables, so validation of surveys is different, right? So we typically do what's called pre-testing, which is do cognitive interviews to understand if the question is not being understood the way it's being understood. We usually do focus groups for surveys to see if there's some, again, if the options are all mutually exclusive, if there is some technical inaccuracies, you know. So there isn't concerns about the internal structure because you are not measuring latent variables, right? So surveys you pre-test question by question, okay, and it's all about technical accuracy. Can they reliably recall this? I actually, as a matter of fact, if you're curious, I'm teaching a survey methods class right now, and I can pull it out and show you my my pre-testing lesson. It looks completely different from what we are talking about. Because again, you're not measuring latent variables, so.
I'm lost. Surveys versus scales. Scales ask questions. Surveys ask questions.
But they're completely different purposes.
Give me an example.
I have a perfect slide about that because it's the first topic on my
So lost.
on my class.
A scale is a survey.
It's not.
Oh,
Different.
well, I'm pulling up all
wait
these
a minute.
scales
You'll
and I'm
see.
gonna make it into a survey. I'm gonna convert it into a survey.
An observer could rate on
If
the
you
scale,
put
too.
if you put multiple, if you can put the scale within a survey, but which means you are putting a bunch of things together. But the scale is that piece that measures the latent variable. It's not the whole survey. So they're not synonyms.
You gotta show me a survey, I guess.
Yeah, I
If you
will.
open a question in a survey, that's not a scale.
No, but a scale
Okay,
is a
just
survey
bear with
type
me.
of survey,
You'll
though.
get your answer as soon as this
It can be a
PowerPoint
question
opens.
and answer.
Okay, why don't we just let him, he'll show
Yeah,
it.
yeah, okay. Here. Sorry. Differences between psychometric scales and surveys. So psychometric scales, several items to measure a single construct. I think about Mains and Potsakov. Think about the constructive voice. Several items to measure a constructive voice. The items are highly correlated because they're measuring. I can send you guys this
I
PowerPoint.
say.
Yeah.
Send it.
Yeah. No, I can send you the whole PowerPoint.
Okay,
Yeah.
perfect. Thank
It's
you.
not in Canvas?
No.
Well, this is not for this class.
Not for this class.
I did not, I'm going on a tangent because you guys need clarification of the difference. This is for my survey methods class.
Please,
Yeah. So they measure, psychometric scales measure latent variables, right? Therefore, the items need to be strongly related to each other because they are measuring the same construct. Job performance is a latent variable. Surveys, the items are not related to each other. You can have a question, what's your gender? Then a question, what you ate for breakfast? Then a question, what brand of car do you drive? That's perfectly fine for a survey. You are measuring observed.
No, this all makes sense. I was lost because in order to do a scale, you have to do a survey to get the data for the scale.
Technically you are doing a battery. Like you are putting,
A battery, okay.
Yeah, you are putting some scales within a survey, but the survey part are your observed variables. The scale part is your measures of a latent variable. So you're combining things that doesn't make the whole thing a scale, right? The scale is just so for example, if you put your job performance measures within the survey, right? And you say, what's your gender, what's your years of experience, and your measures of job performance. The scale part is just the measures of job performance. The rest is the survey.
Got it.
So don't confuse, you can't mix them together.
Yeah.
That doesn't mean that, we are the same. Yes?
But in both spots you have attitude. So let's take enjoyment. If I'm trying to collect data on enjoyment of a lesson for a student, do I need to find a psychometric scale?
Yes.
Yes.
Unless you are treating it as an observer variable, unless you have a single item say, how much do you enjoy this lesson? Strongly agree to strongly disagree. That's a single item. You are measuring a latent construct, but you are measuring it poorly because you cannot, with one item, you cannot separate measured error from the latent variable.
Okay.
That happens a lot with job satisfaction.
Yeah.
Job satisfaction is a latent variable, but people usually treat it as an observed variable and put one question in the survey: how satisfied are you with your current job? Strongly agree to strongly disagree. It doesn't mean that it doesn't mean it's not a latent variable. It's just you are not measuring it that way because you have a single item.
So so you were saying earlier, maybe the reason why they asked multiple questions worded similarly is so you have that total sum that has more variability. Earlier you're talking about that?
No, it's because you are trying to separate. We talked about this. We should avoid summing because if it's a latent variable, summing the items ignores measurement error and assumes that they are equal measures of the construct.
Okay, but let's go to that one and say we've got a lot of similarly questioned. Most of these scales have a lot of questions that ask things similarly.
They must.
The advantage
They
is
must.
why?
Because you are able to separate measured error from the part of the variability that's due to the latent variable.
So if
Is it
somebody,
kind of asking the same question different way, is it?
Yes. Think about this. You are taking. Let me go back to a very an example related to achievement, right? Let's say I'm trying to measure your mathematics ability, right? Let's say algebra, right? If I give you a single question, a single algebra question, I have to treat it as an observed variable, and I cannot separate the measurement error. Like maybe other things that are being measured besides algebra. Now, if I give you 5 algebra questions, then I can separate your algebra ability from the measurement error, right? If I give you 20 algebra questions, I can do even better.
sure,
You know,
that's great.
That's why.
That's great.
So the question you asked yesterday to David, or to everybody, and David said yes, it might be no. You asked if you're changing the validity.
Did I ask
I think that's what
if
you
you were
asked.
using for a different context or if you were removing some items?
So what you mean by that, if I'm measuring, for example, the use of power, that validity measurement is already created. I cannot take or add questions to that, but I
Without
can
having to do another.
revalidate it.
Yes.
Okay, but I can add like gender, age, deployment
Yes.
for military, but the validation system stays the same.
Yes, because gender, military, those are observed variables. They actually have nothing to do with the latent variable.
That helps. Did you
Yeah.
get it, David?
That helps, yeah, it's very, very helpful.
I'm so glad
So
this
in my
came
in
up.
my class,
Yeah.
this is okay. The reason I show these students this slide first is because I tell them, if you are in this class to learn how to validate a psychometric scale, you are in the wrong class. Now you guys is the opposite. If you're here to learn about surveys, you are in the wrong class because this class is about scales, right? And so,
Which is part of the survey.
Which is part of
And that's what I was, exactly, that's what's throwing me off.
Yeah,
You
but-
can't collect the data without a survey.
Well, yes, but first, it's not necessary, right? You can administer the scale by themselves, right? You were thinking about self-administered through online, but like you can, for example, she's probably setting an experiment. Like if you have the students in a room, you
Yeah.
don't need a survey. You just give them.
I'm saying I can't. I should just, I'm personalizing to me. It's all about me.
Give an
I
example.
cannot get my
Give an
psychometric
example.
scales
Like if you are
without
a
surveys.
scale can be administered by itself. You know, like so. For example, if I have a personality inventory here, I can just hand them to you, and it's not a survey. That I won't be. I just give you the scale.
But it's not a survey. What is it then?
A survey is a set of observed questions that are put together, right? If I'm giving, let's say, if I give you a single
Survey
scale,
can be
I'm
a
not
scale,
giving you a
but
survey.
scale is not always a survey.
Right.
So think of it like
A survey may contain a scale,
That's right.
Right.
but a scale does not need to be in a survey, you know? So think about a survey as a bag of questions, right? You can put a scale in the same bag of questions as a survey. A survey only measures observable things, right? If you put in the same bag and administer it together, it doesn't make a scale a survey. It's still a scale. You just administer it together, right? So let me show you. Let me give you.
There's other tools than surveys.
I
like
can give you
in web-
I can give you an example from my own. I've administered several in that situation. Look at this. I'm gonna pull up my Qualtrics. Qualtrics.ufl. Oh, sorry, it's ufl.qualtrics. ufl.qualtrics. Okay. So this is my my Qualtrics, which I use to implement both surveys and scales, but Qualtrics is meant for surveys. Now look at, I'll contrast two different things, right? Look at this one. I published this as a survey that I survey teachers about how they use Algebra Nation, which is a learning platform, during the pandemic. So I administered this in spring 2020, right? Look at the questions. They are not measuring latent variables, like how has your teaching of algebra been impacted by the current school closure? How much did you use the following result? How much did your use of the following resource change since schools closed and you shift to online instruction? You know, these, I don't need to do confirmatory effect analysis on these. I report them one by one. It's not measuring a latent variable. Since the schools closed, to what extent are you able to follow us in advance? Okay, now compare this survey with this one, which I also administered in Qualtrics. When a study does better than usual in mathematics, it's often because I exert a little extra effort. I continually find better ways to teach mathematics. Even if I try very hard, I do not teach mathematics as well as I do most other subjects.
That's a validated scale?
That's a scale. I administered it as part of a survey. It doesn't make it a survey because these three items are measuring mathematics self-efficacy. which is a latent variable, right? So don't confuse the method of administration with what the instrument is. This was administered as a survey, but the content is actually a scale.
Mm-hmm.
And that has been validated by somebody already,
Yes.
you just using it.
Yes, I
You just
chose-
tweaked it to have a
I did not
mathematics
tweak it.
angle.
You
I did
cannot
not
tweak
tweak.
it. You can
To
add
avoid-
questions like gender.
You know,
Well,
you
yes,
didn't.
but those are I added, obviously, at the end of the survey, I
It,
added.
it was a mathematics specific scale, or did you
Yes.
add the mathematic part
No,
in?
it was validated. There are so many scales.
But you could take that and manipulate it to your field.
I would have to provide validity evidence if I took it.
Okay.
If you were adapting, when you adapt a scale, the validity evidence obtained in the previous study does not.
And we're going to cover how to do that.
You did already. You do a confirmatory factor analysis.
That's what we did.
That you
day
did.
one.
Okay. When I have to go back through all of it.
Yeah, that's exactly. And you report reliability, report model fit. That's what you do. Okay.
Why did you use 5 instead of 7 on the strongly agreed?
I did not develop this scale.
It was already developed.
Yeah, no, it's complicated to develop. Like someone did the same process as Mains and Potsdam. Okay. Now, I mean, if you want to learn how to do a survey, there is a single book that you need, which is the Bible of surveys, which is Don Gilman, this book here. Let me. Gilman survey methods. Oh, there is a 5th edition, a 4th edition. This is the older edition. Why Amazon is pulling up the older edition? That is even older. This one here. That's the book I used in my survey methods class. Okay? That's the book that teaches you how to do surveys. So it has nothing about scales. It doesn't talk about confirmatory factor analysis, validation. It's about developing questions that will be understood consistently by respondents, and you will maximize response rate. Yeah. And it's the Bible of survey methods.
So I guess it's kind of a terminology thing. Like if I'm doing a mixed method and I'm doing a interview, plus I'm validating through a survey. Is that correct? I'm using a validating method through a survey. Is that correct?
That seems unusual to me. Usually it's the other way around. You try to test the questions in a survey through interviews, because interviews give you the fine grain, right?
The interview is kind of to find the hypothesis and the idea.
Oh no, then it's completely different purpose, right? You're using your interviews as a hypothesis generation. It's mixed methods research. Yeah. It has nothing to do with validation of anything. You may be saying that you are validating your hypothesis, but you're not really. You're generating a hypothesis. Yeah. Yeah. So we don't call about validating a survey. We call pre-testing a survey. You validate a scale. You pre-test a survey. Pre-testing a survey is focus groups, pilot tests, cognitive interviews. Respond to debriefing, you have them complete the survey, and then you call them up or do a Zoom where you ask them questions about how they answered your survey. That's how you do survey. Also, I have a whole PowerPoint about that because I teach this stuff. Okay.
Can we have that too?
Yeah. Sure. Okay. Yeah. I guess it's this class is about latent variable models. That's why I don't go to it. Now there is one last thing I want to teach you, which is something that you need for the exercise, but it's also very helpful in general. What if you only have a composite, but you want to treat it as a latent variable. Okay. Now remember that you need. We talked about. How you need at least 3 items, right, to have at least 0 degrees of freedom. In other words, to be able to fit a confirmatory factor analysis. But what if, like, let me give you as an example. Like, you said that you have multiple scores of performance, right? And that's ideal. But let's say the company that's giving you those scores, they tell you, no, we will not give you the disaggregated scores. All that we're going to give you is the sum of them. So you will get a performance metric, but that's the sum, but they will not give you the components. All you have is the composite. Okay? Well, you could use it as just an observed variable, but there is a better way. And the better way is to do this here. Now, you cannot fit this like it is, because even with setting this 1 and setting this 1, you don't have enough degrees of freedom here. This will not fit. Okay, the degrees of freedom are negative. So there is a trick to doing this, and the trick is if you happens to have Cronbach's alpha of the composite. Let's say that you know that the reliability of performance is 0.8. Cronbach's alpha of performance is 0.8. What you can do is fit this model like this, but set up the error variance here. So the variance of error to be equal to the variance of performance times 1 minus reliability, right? So in this case, it would be, since reliability is 0.8, you would set this up as 0.2, okay? Therefore, you would be able to have a latent variable measured by a single indicator, because you are using Cronbach's alpha to adjust for measurement error. Okay, so that's a trick that is useful in some cases where it's a situation where you only have the composite, but you know what the reliability is.
Where did you get the 0.8 from?
You would have to know it either you calculated it previously or someone told you what the reliability is. Here I made up, right? I said, suppose your Cronbach's alpha is 0.8, but you would have to know it. Now let's apply to this situation here. I know reliability for LRB1 is 0.92, right? What if I did not have LRB1, I only had the sum of x1 plus x2 plus x3. Okay, I could use that sum here, but I would say that the error variance equals 1 minus 0.932, right, which is the 0.68, right? So the error variance is 0.068 times the observed variance of the variable. Okay. It's a handy trick. It's not always that you need that, but it does happen. Zane and Bartol, the article that you reviewed, had to do that. I do have a go back to our class here to show you. Here, this video. SM example two variation. Structure equation model with single indicator where I replace a latent variable that has multiple indicators by one that's measured by just one indicator. Okay. Another situation that you may need this is you try to measure job performance and you thought you would have 3, but you only get 1. Right? Now, if you don't have reliability, you have to make an additional assumption. You have to say that measurement error is 0. Like, so you can still fit that, right? Saying that this equals 0. It's not ideal, but it's better than nothing. So let me show you. Let's make that simulate that situation here. This model here. Let's say that you originally wanted these 4 measures of performance, but you did not get them. So I'm going to delete. Go back here. This was your plan, but it did not work out. You only got Y1. That's all you have. This model will not fit because you don't have enough degrees of freedom on this part. Unless you go here and you set under parameters and you set the error variance, right? If you know what Cronbach's alpha is, then it's better because you can do 1 minus Cronbach's alpha times the variance, right? So this variable here is, I converted it to z-score, so the variance is 1. Therefore, and let's say Cronbach's alpha is 0.9, right? So I would do 1 minus 0.9. The error variance would be 0.1, right? Now this model would fit, but I had to make a sacrifice. I had to set the error variance to a value that I consider reasonable because it's 1 minus Cronbach's alpha. Okay, and it's 1 minus. Remember, it's always 1 minus Cronbach's alpha times the variance of the variable. If the variable is standardized, the variance is 1, so it becomes 1 minus Cronbach's alpha.
And if you don't know the Cronbach's alpha, you said you could set it
to 0. But again, another sacrifice. You were saying that, so let's say you don't know the Cronbach's alpha, then you do this, 0.
Yeah.
Then you were saying this variable is perfectly reliable. Okay, it's a limitation. You're assuming that the variable is perfectly reliable. It's probably not.
Why wouldn't you be conservative and just put like 0.1?
You could. But I guess, yes, you could say, I'm assuming that, 90% the reliability is 0.9. You could, yeah, you could even, you could even be more, that's a good point. You could even be more conservative, say, I think this variable has at least a 0.7 reliability. I have never seen that done, but you make it a very good point that you could say, I don't know what the reliability,
I'm out.
yeah. I
And
don't
on
know
a good
what
note.
the reliability is. I'm assuming it's not awful. It's at least 0.7.
Yeah.
Right? And so standardize the variable. The variance is 1, so 1 times 0.3, because 1 minus 0.7. And that would be, you were saying, it's not perfect, but it's not awful. And then you can fit this model, run.
Well, you would just try it a bunch of times. It goes to go for point 1, works. Point 2 still works. Point 3 doesn't work. Okay, I'm back to point 2.
That's cheating.
I know.
Yeah. But assumptions are not unreasonable. If you explain, say this has been used, I can even cite another study that's, because reliability you can only estimate with your own data, right? But you can cite another study saying, in another study, they found reliability of 0.7, therefore I don't have reliability here, I cannot calculate because they didn't give me, if they don't give you the items, you cannot calculate from X alpha.
Mm-hmm.
But you can make that assumption based on a previous study, cite it. Yeah, that's the solution. Yeah. So
You can even cite stuff incorrectly according to the last paper.
You can, which I assume it happens. Actually, I know it happens a lot. Where people cite something without reading. Say, oh, Bates and Potsakov recommended this method. No, they actually criticized the method.
Crazy.
I'm guilty of that.
Bless
So conceptually, reliability and error are reciprocals, and mathematically.
Yes, they are. The more error, less reliability. It goes on the definition. But everything is online there for you guys. And I can, so you can watch my video, see me doing all of this again, and so you can do the assignment.
I will absolutely watch all of these videos and download them and save them. But after this class is over and my survey scale results come back in like end of July, would you be open to office hours just to review some stuff? Post class?
I am open to answer emails, and if you are in a particularly hairy situation, like emails is always the best way. If I can find the time, but again, I'm not your advisor, right? Like I'm not your committee. I have been committees here, but it's not my role. So there is a limit in the amount I can help.
Understood.
But I can always, I have so many resources, I can send you the right way.
Perfect.
No problem.
Do you have a good book or resource on shrinking scales down?
Well, papers.
Or papers?
Yes, papers. I email me.
I'll email you, and just a reminder if that would be something that would be helpful for me.
I'll be good with discussion board, I think, so we can all.
Or
Sure.
give it to all of us.
Which actually let me, which reminds me, since I'm here, I can post some of the resources here. I'm putting some things from my survey research methods class. For the short form development, I have so many things. I have to see what is really introductory. Like I actually have a paper that I published on proposing a method to develop short forms. It has been cited a few number of times, but mine is computational, and I wrote an R package for it. You don't want to use my method because you need R, and it's probably overkill in your case. And my method is about when the study is about developing a short form. So like you actually have to collect data on the full form.
Oh,
Then do the study to validate, which is not.
that doesn't help.
Yeah, but we do have a discussion about that. That's part of our discussion. So. Putting pre-testing here, pre-testing methods, cognitive interviews. I mean, if you guys are in marketing, it's not that different. Cognitive interviews from what people do for like user experience. It's like a lot of things that we do for surveys. It's similar to user experience research.
Thanks for these.
Any other questions? Things I can elaborate? You want to ask about your specific situation?
I have a question about money, but I can catch you when we finish.
Oh, okay. Yeah.
Thank you.
So just remember that we starting that we have a nice schedule of discussions here, including create a short form, one about interactions, about alternative models, about scale salesperson is one of my favorite because you were trying to say a scale is a good scale. You know, I did have a student last week. He must be in sales. He did an excellent job convincing others in the class that was a good scale, even though it was a terrible scale. I actually had to, usually I just let you guys discuss it and I only comment on the individual feedback. But in this case, I had to post on the feedback to everybody else that, wonderful job promoting the scale, but this is a terrible scale because of this, and that. Because I don't know, I actually, to this day, I don't know if he really believed it was a good scale, he just made a great job selling it, or if he was like devil's advocate, he knew it was problematic and sold it anyway, you know.
Maybe you just put in ChatGPT and said, make this sound like a good scale.
Yeah. Yes.
Can you touch on the assignment that's due between now and next residency?
Oh, yes. So that assignment is really your major hands-on experience. You will, okay, I have instructions.doc here. So assignment instructions. So you read Zeng and Bartol, right? First, you will use a quiz that I implemented on campus to rate. So I asked a series of open-ended questions with some closed-ended questions too, for you to evaluate Zeng and Bartol. And the objective of this rating form here is for you to be able to think about all the parts of the article. Okay, and once you complete this, yeah,
Is it untimed, the quiz, and if we can start the quiz and come back out?
I think
It said unlimited attempts.
I put a limited attempts.
Gotcha.
I would say print it as PDF or copy and paste. I will revise the settings to make sure you can see all the questions at once. Let me just double check. Assignments. Article rating for assignment.
Says no time limit.
Yeah, that is good. double potents. Okay, let me take this out. Show one question at a time. So you'll be able to see the whole thing.
Thank you.
And then you have to, so and then you have to redo the analysis. So I provide the data, and you reanalyze it. So in the reanalysis, so you use AMOS to estimate the measurement model. And I put some comments here, so you don't, to clarify some things, right? So there is moderation, but the author actually doesn't use SEM to test moderation. You are expected to use SEM, so you have to include the interaction involving power, role, identity, and leader encouragement of creativity using SEM, using the method shown in class. So you can choose here if you want to do the product of factor scores method or the product indicator method. Okay, I showed both, either one is acceptable. Also, this is something the author does. It's a bit hidden in the article, but it's there. They include employee creativity and intrinsic motivation as latent variables measured by single indicators. So they do this. Okay, so you have to do that as well. So you do the drawing, provide the outputs, and then so all of this is rerunning, but then you have to provide tables, but also interpret them. So factor load is I-squared, average of average extracted composite reliability, which is what I showed today, instead of convex alpha. And then you have to estimate direct and indirect total effects, like I showed yesterday. Where you get the decomposition. You have to run bootstrapping to get the standard errors and confidence intervals. So basically, this assignment is you doing everything we did yesterday and Friday, right? Like all the things we did in CFA, and then all the things we did in SEM. And after you do this, you be more comfortable doing it.
We have to do interactions as well?
Yes, that's where this says, like,
okay.
Moderation here.
Okay.
Like between empowerment, role identity, and leader encouragement of creativity. Okay? And one thing that I should point out, because people get this wrong a lot, every time you do an interaction, you should always have the main effects, right? So let me.
Before you do that question, when you wrote that performance right there, and then you had the equation, it was performance, then it was times 1 minus performance?
Times the variance of performance, which if you standardize performance, like if you make it a z-score, the variance is 1, so you can drop that. If you don't standardize, you have to use SPSS to get what the variance is, so you can multiply. Okay, so I recommend standardizing.
So standardize, it's performance, it's a composite, it's performance times then 1 minus the
is the variance of performance times 1 minus reliability. Because you are just putting this in the model, right? You are not modifying the data. Yeah. So if you make performance standardized, then it just becomes 1 minus convex alpha or composite, whatever reliability you have. have this in the, okay, you see. My point here about the interaction is this. Remember that I said, people represent interactions, let's say, performance. People represent interactions this way, right, in diagrams. But obviously, in statistical terms, this doesn't mean anything. What we are actually doing is this here. And we need vigor, and then we need a product here, right? LRC times vigor. And we know this because we talked about it. This means this. But a mistake I see is that people put the interaction, but they don't put this. Right? Is an interaction without actually having the main effect here. And you should never do that. Like, if you have an interaction, the interaction should be above and beyond the direct effect. Right? So always don't forget about adding the direct effect in addition to the interaction. Okay? And I guess the reason people forget is because they get caught up on the drawing here and forget that there should be a direct effect here as well. Okay? Even if your theory doesn't, even if you don't have a hypothesis about it, even if your hypothesis is just about the interaction, like you have a hypothesis about LRC, let's say hypothesis 1, that LRC affects performance. Hypothesis 2, the effect of LRC on performance depends on vigor, right? That's a hypothesis about the interaction. You don't have a hypothesis that vigor affects performance. You don't have a hypothesis about the direct effect of vigor. You still should add it in the model because it's misleading if you don't. Okay, because the interaction should be cumulative on the main effect. Okay?
Why is performance in this case in a circle and not in a square?
Because I'm assuming I have indicators here. I'm simplifying because we're in a hurry, right? But it's a latent variable. Yeah. I'm doing a conceptual model here. Okay. We're right on time. That's not the noise my phone makes.